Hello, it's me, Mr. Werger. We're going to do a second lesson on limits today. If you remember last time, we talked about assuming that a function was continuous, trying to plug in that value that x was approaching. If that didn't work, then we used factoring or some other method of simplifying. So that hopefully something would cancel out, so that when we plugged in our given x value, we got a real number answer. Okay? So not every function factors, which you probably realized. So the first part of today's lesson is called What If Factoring Doesn't Work? Okay? So looking at example 1, we're looking at the limit as x goes to 0 of the cosine of x minus 1 over x. Okay, so first we try plugging in 0. So that would be the cosine of 0 minus 1 over 0. And if you remember from the unit circle, the cosine of 0 is 1. That's 0.10. So the cosine of 0 is 1, so we've got 1 minus 1, so we've got 0 over 0 there. Okay, so the next step we would do would be to factor. This does not factor. I really hope you wouldn't cancel out the x's there. If there's an x in front of the cosine, that could be canceled, but this represents an angle, so you can't cancel that out with just a plain x on the bottom. Okay, so this does not factor. So, if factoring is not an option, factoring is not an option, we're going to look at either a table or a graph on our calculators. Look at a graph or table on your calculator. Okay. So we can hit pause for a minute so everyone can get out their calculators if you want to follow along here. So on your calculator, first you might need to go to mode, and we want to be in just plain function mode, not polar, parametric, any of that stuff from chapter 6. Go back to regular y equals x function mode. And why don't we go to radians here? Oops. So we have cosine in this function. Okay, so then we need to put parentheses around that numerator. So parenthesis cosine x, and then a parenthesis minus 1 parenthesis divided by x. Okay, and we might want to do a zoom 6 and a zoom 5. That resets your window. Maybe just a zoom 6. Okay, so maybe we should zoom in a little bit on that. There's not much happening when x is bigger than 2 and less than negative 2. Or sorry, y. I'm going to knock that down to maybe 5 and negative 5. Oops. Negative 5 and 5 in the x direction. Negative 2 and 2 in the y direction. Looks a little bit like a sine graph, doesn't it? Okay. So if you want to kind of sketch what that graph looks like. So it's kind of going along, and then it comes up, goes down, kind of goes like that. Okay, and we are interested in the limit as x approaches 0. Okay, so we did a graphing example last time. So looking at the graphs, if I'm moving along the curve and I'm getting closer and closer and closer to 0 for x, what y value am I approaching? So we'd be approaching 0, right? So the value of this limit as x goes to 0 equals 0. Okay. The other thing we can do is look at a table. We haven't done much with tables this year. First, go to Table Set, which is above your window button. So that's second window for Table Set. Okay. This is actually not too bad. Usually you want your table to start, at the value that x is approaching. So x is approaching 0, so I could just type in a 0 there. And then there's a little triangle, so that's the Greek letter delta table. So delta means change. So this is the increment that our table is going to go up. So you want something pretty small there. So I've got 0.001. I think that's a good value to have there. So table start at 0, delta table 0.001. So then hit second, and then the graph button, and that gives you a table. And if I just go up a couple here, okay, so when x is 0, the table says error, which is what we got when we plugged in 0 before we started the calculator part, right? So it's undefined when x is 0. So then we're looking like on either side of 0 at these numbers. So I've got 5e to the negative 4th. Should we recreate the table here? Recreate the table. X, y. So I've got negative 0.001, and that was 5e negative 4. And then at 0, it said error. Positive 0.001, it said negative 5, E4, E negative 4, negative 5, E negative 4. Okay, so 5E negative 4, that's scientific notation. So that's 0.0005. We have four values to the right of the decimal place. And negative 5e negative 4 would be negative 0.0005. Okay, so those two values are pretty close to 0, right? So the table is telling you the same thing that the graph did. So there's just a couple of options here. So looking at these two numbers, they're pretty close to 0, so we can say the limit is 0. Okay? So if you'd like to pause for a minute and try the second one on your own and see what you come up with? Why don't you do that? Okay, so I don't know if any of you tried plugging in 0. You'd have the natural log of 0 plus 1 over the sine of 0. So the natural log of 1 is 0. And the sine of 0 is also 0. Okay, so we need to do something beyond just plugging in 0. Obviously it doesn't factor. We've got natural log in the numerator, sine in the denominator, so can't do anything with that. So this is another good example to either graph or look at a table. Okay, so in your y equals screen, clear that out. I'm going to put parentheses around my entire numerator. So parentheses, natural log of x plus 1 parentheses. You might not need the second set of parentheses there. I don't know. I'd rather be safe than sorry. Over the sine of x, right? Okay. Okay, so again, we're looking as x approaches 0. So as x approaches 0, it's approaching the y-axis. So from either side there, kind of looks like it's approaching 1. If I look at the table, so second graph, we'll look at the table. Okay, so on either side of 0 there, I've got 0.9995 and 1.0005. So right in between those would be 1, right? Okay. So this limit is equal to 1. So that's the first part of our lesson. The homework associated with this is worksheet 25. And the first 12 problems, you do not need a calculator. Those are similar to the problems we did last week. But it's the last 3 problems, 11, 12, and 13. Those are the ones where factoring is not going to help you. And that's where you would need to use a graphic table. Okay? Then the second part of our lesson is limits as x approaches infinity. Okay, and we did these back first semester. I think we did kind of the same thing a couple times, so this should be a review. Looking at these fractions, so 1 over 10 is 0.1, 1 over 1,000, 0.001, 1 over a million, 0.0000001. So what is happening in these examples? So the denominator is getting larger, right? And when the denominator gets larger, the value of the fraction gets smaller. And it gets closer to 0, right? What is happening in these examples? As the denominator gets bigger, the value of the fraction gets smaller. The value of the fraction gets smaller. So the denominator gets bigger, so if we make the denominator as big as it can possibly be, so that would be represented by infinity, then the value of the fraction gets really, 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 really close to 0, right? It's like I'd have points and then my zeros would just keep going. And I would never get to the point where I could put a 1 on the end because the denominator just gets bigger and bigger. Okay, so 1 over infinity, and we did this first semester. We're going to say that's basically 0. Okay, and it doesn't really matter what's in the numerator, so if I have 5 over infinity, that's still going to be 0. Okay, so here's a limit as x approaches infinity. 5x minus 3 over 2x plus 7. Okay, so we're going to plug in infinity for x. Plug in infinity for x. Okay, so so if I do that, I get 5 times infinity minus 3 over 2 times infinity plus 7. And, 5 times infinity minus 3 is still infinity. 2 times infinity plus 7 is still infinity. Okay, so we're getting infinity over infinity, and we don't want that. Do not want this. Okay, this doesn't really have any meaning to us. You might think it's equal to 1, but it's not because the numerator and denominator are not the same, so it's not equal to 1. But it's not equal to infinity either, so we gotta do something other than just straight plugging in infinity. Okay? So when this happens, and again we did this earlier in the year, remember we divided by the largest power of x in the denominator? Okay, so do not want this. So then divide every term by the largest power of x in the denominator. Divide every term by the largest power of x in the denominator. Okay, so yeah, I can just fit it in here. So I'm going to divide everything by x. Okay, and then do some simplifying. So 5x divided by x is just 5. Can't do anything with 3 over x. In the denominator, 2x over x is 2. 7 over x. Okay. Now if I plug in infinity for x, I have 3 divided by infinity, which we said was 0. 7 divided by infinity is 0. So now I'm just left with 5 over 2. Okay. And again, we did that first semester with horizontal asymptotes. And then we also did it with infinite series. maybe it was infinite sequences where the terms just kept going to infinity. Okay, so you get 5 over 2 there. Let's do a couple more of those. So here, if you plug in infinity, I mean, you're going to get infinity squared minus infinity plus 2. So 5 times infinity plus 1. Okay, so you're still getting infinity over infinity there. So divide by the largest power of x in the denominator. So that's x to the first again here. Okay, so x squared divided by x is x. 3x over x is 3 plus 2 over x. And our denominator is 5 plus 1 over x. So then we plug in infinity for our x's. There's 3 of them left there. Okay, so 2 over infinity is 0. 1 over infinity is 0. Okay, but I still have infinity minus 3 over 5, which is infinity. Okay. So the answer is not infinity. We're going to pause here. We're going to do a video within a video. I've never done this before, but I hope it works. So my sub should have a link to this video. So if you want to go ahead and play that on the smartboard, hit pause with me here, and then we'll come back and discuss what you saw in the video. Okay, I hope that worked. Has anyone seen that movie before? Maybe a few of you, okay. So if you get something like this, then the answer is going to be the limit does not exist. The limit does not exist. Okay, don't write infinity, don't write undefined, don't write no solution. None of those terms apply here. So if you're trying to find a limit and you get infinity, you say the limit does not exist. Okay. Okay, final example. So here the largest power of x in the denominator is x to the third. So we're dividing every term by x to the third. So 2x squared divided by x to the third. So I could cancel the x squared with 2 x's in the denominator. I would still have 1 left, 1x in the denominator. So that's 2 over x plus 7 over x to the third. Denominator 3x cubed divided by x cubed is just 3 plus 8 over x squared minus 2 over x to the third. Plug in infinity for x. Any constant divided by infinity is 0. So I'm left with 0 over 3, which is 0. So as your x values get bigger and bigger and bigger and bigger, the value of this fraction is going to very, very, very close to 0. Okay. Okay, so the homework associated with this part of the lesson is worksheet 26. I think we'll take a little work break now, work on those 2 assignments if you're watching this in class, if you're working on it on your own. I guess you're working on your homework anyway. Then in about 20 minutes, there's a 3rd video. It's a vintage pre-calc video from many years ago. Hope you enjoy it. It's a little review of logarithms. And then you're going to do worksheet 6, which is a little more practice with logarithms. Okay. Have a good rest of your day, and I will see you next class period.